Welcome to the Dream Catcher. We begin with ratio lesson 2. Today we follow the book Ganit Prakash. Please come to chapter 5. We're today doing exercise 5.1, page number 82. The expected marks from this chapter is 1 MCQ, 1 fill in the blanks or 1 true and false, each of 1 marks. And you could also get 1 2 mark question from here and 1 3 marks question from this chapter. We start with question number 1. And we choose question number 4 to do it. So the question says us to express the following as ratios. So remember, ratio has no SI units. So this is our concept here, that we change the first term and the second term of the ratio in the same SI units. So we take the first one, required ratio is equals to 1.2 kg is to 60 grams. Here we are choosing to change kg into grams. 1 kg is 1000 grams, so that the SI units are the same and it gets cancelled. We left with that, we cancel that with 60, and the answer is 20 is to 1. We could also choose to change grams into kg, so it is dependent on you. So 1 gram is 1 by 1000 kg, so 60 gets divided by 1000. We can cancel the SI units, and then we have 12 by 10 is to 60 by 1000. Now you could see the bases are not the same. We have to make them into equivalent fraction. We have learned this in the previous lesson. So multiplying both numerator and denominator with 100 so that the denominators can be the same. After the denominators become the same, we could cancel it, and we can cancel this with 60. And our observation is it does not matter whether you change the first term or the second term. Okay, the answer will still remain the same. We start with question number 2. Let us write the ratio of p kg and q grams. I hope everybody can do that. Let us write when it is possible to find whether it is possible to find the ratio of x days and z months. Yes, because days can be changed into months and months can be changed into days. Let us write what type of mixed ratio of a ratio and is inverse. So the answer would be the ratio of equality. It is only possible for a ratio of equality. Let us find the mixed ratio of. Now there are 3 ratios, okay, and if nothing is mentioned in the denominator, there is always 1. Remember, when we find mixed ratios, we multiply all the antecedents on one side and all the consequence on the other. So the first term would be the multiplication, the product of all the antecedents, and the second term would be the product of all the consequence. So I'm still not doing question number 4. Today we discuss question number 5. Let us write by calculating what ratio and x square is to 4z will form the mixed ratio. So very important thing to know here is what ratio the question says. So we do not know the ratio actually. So there are 2 ratios and we have found the mixed ratio of it, and the mixed ratio of it is xy is to z square. Since we do not know the ratio, let the required ratio be a is to b. How to find the mixed ratio, compound ratio? We multiply both the ratios. So this is our first ratio, a is to b, and our next ratio is x square by 4z. We are writing this in the form of a fraction, and the question also tells us what is the mixed ratio. So the mixed ratio is xy by z square is equals to what we know. Now we are going to cross multiply this. This is going to go to the numerator and this is going to go to the denominator. Why are we doing this? Because we are finding a by b, so we are keeping it on one side. Then you could cancel the terms. X square, the square and the x can get cancelled, and the square and the z can get cancelled. Now what is remaining in the numerator? You see y into y square, and in the denominator we have z into x. So that would be our answer. Now we discuss question number 6. Let us calculate compound ratio of inverse ratio of. See, so first we need to find the inverse ratio of all these terms, then we'll find the compound ratio of it. So the inverse ratio of all these terms that is given to us is just the opposite of this. I hope everyone remembers. Now we know the inverse, okay, and we need to find the compound ratio of the inverse, means this ratios, that is yz by x is to x square, zx by y is to y square, yx by z is to z square, these terms, okay, not the one which is given in the question. And remember what is mixed ratio, compound ratio, okay. It, like I told you before, it is the product of all the antecedents. So if you look at all the inverse, we have multiplied only the antecedents, we have taken the first terms only, is to, then we multiply only the second terms. So this is the easiest way to do it. Again, remember, it is a product of antecedents is to product of consequence. So that is what we have applied here. So you could see we could cancel certain terms, x and x can get cancelled, z and z also can get cancelled, and y and y also can get cancelled. So what is remaining in the numerator you see is y into z into x. We are writing that as x y z is to, here we have x square, y square and z square. So this cannot be changed, but we can simplify this and write it as a whole square, since all the terms have a square. Now xyz into 1 and the square can get cancelled. So what is left is 1 is to xyz. So this would be our answer. Question number 3 I'm not discussing because it's all about finding the mixed and compound ratio. It's quite easy to do that. Question number 4, we start with question number 4, which is question number 4. Very important to understand question number 4. So there are two ways to do it. I'll be discussing both the ways. You may always choose any of the way to solve this kind of questions. So if you look at the question gives us two ratios, x is to y and y is to z. When we look at it, then we find a common term, that is y. And when you look at both the ratios, y is not the same. In the first ratio, y is 3. In the second ratio, we can say y is 4. So we can see there is a difference between the two. And if there is a difference, we will not be able to compare these two. These two terms, the values of y which is given here in the ratio has to be the same. So that is what we try to do. Let me first write this in the form of a fraction. So which terms am I talking about? You can see 3 and you are talking about 4. Okay. Now what we can do to make it same in ratios, we can always find the LCM of the terms. Okay. So we have 3 and 4. So the LCM of 3 and 4 would be 12. So we'll try to make the value of y in the first ratio also 12 and the value of y in the second ratio also as 12. So this is what we are going to do. We're going to multiply these terms with 4, so that 3 4s is 12. For the second one, we're going to multiply that with 3, so that it is 12. So the first ratio gives us 8 by 12 and the second one gives us 12 by 21. Now you see, we have a single value of x, that is 8. We have a single value of y, that is 12 in the first ratio, also in the second ratio, and we have a single value of z, that is 21. So we can say x is to y is to z is 8 is to 12 is to 21. This is how we can write the answer. And if the question tells us find out what is x is to z, after doing this step you can see what is x, 8, what is z, 21. So you can also write that answer, that x is to z is 8 is to 21. Now this is slightly longer way. See if you can understand this. This is a much shorter way that we are going to learn. Same question, we take a table. Please draw this table. You have 3 terms in the ratio x, y and z, and this is what we know. What we don't know is this term here. I have kept it blank. Now you need to do first fill in the blanks. Okay, so we need to write what will you write in these two blanks. Okay, one by one. This 3 which you see, which is right next to the blank, has to be written there. So we have written 3, and this 4 which is right next to the blank has to be written there, which is 4. Okay, please see the step. Done. Now you can, these two terms which you see for x, we have 2 and 4. 2 and 4 will get multiplied and we get 8. 3 and 4 also will get multiplied and we'll get 12. And 3 and 7 will get multiplied and we get 21. And you see the ratio is 8 is to 12 is to 21. So, and this is a much shorter way to solve this kind of questions. We start with question number 5, number 1, and at the same time the next question that we discuss is question number 6, number 1. So you need to see and observe both the questions. So let's start with this. Given to us is a ratio, x is to y is equals to 3 is to 4. So we know about this, that let the HCF for the ratios be k. We are taking this as k here. We are not taking it as x and y because the question already has x, y. So you should always take any other term. So I am taking it as k. So we can say x is 3k and y is 4k. The concept behind this was discussed in lesson 1. Now we know the value of x and we know the value of y. So the question tells us to find 3y minus x is to 2x plus y. We can first write that in the form of a fraction. And now we replace the values. We know the value of x and we know the value of y. So you see we have replaced the values here. Okay, 3 into 4k minus 3k and 2 into 3k plus 4k. And remember to apply BODMAS. So we first multiply 3 4 ja 12k minus 3k and 2 3s gives us 6k plus 4k. Now you subtract. You'll always find the HCF to be common between the terms, so you will always cancel that, and our answer is 9 is to 10. Now please observe question number 6. This is just the converse of the previous question. Here a particular ratio is given to us and we need to now find x is to y. In the previous question x is to y was given to us. So first let's write what is given. Write this in the form of a fraction. Cross multiply. When we cross multiply, only the denominators go to the other side. So 12 will go to the left hand side and 2x plus 4y will go to the right hand side. So this is what we get after cross multiplication. Then multiply both the terms, 12 into 5x and 12 into 3. And 11 into 2x and 11 into 4. Now we arrange the like terms, that is x will remain on one side and y will remain on other side. So this is how we have arranged the like terms. We have moved it from left hand side to the right hand side. So after you subtract 60 minus 22, you are going to get 38x is equals to 80y. Now try to understand this here. We need to find x is to y, means x by y. So y is going to go to the denominator. Okay, and 38 is also going to go to the denominator. So here cross multiplication is happening. So we get x by y is equals to 80 by 38. So question number 5 and question number 6 are just the converse of each other. You could simply simplify this. Write the ratio always in the simplest form. Start with question number 7. Now question number 7 is a question which relates with both question number 5 and question number 6. So we'll see how. See what is given to us. Okay, we do not know the ratio for x is to y. So first we will try to find the ratio for x is to y. So we'll write this in the form of a fraction, and like the previous question we'll cross multiply this. Then we'll arrange the like terms, x and x on one side and y on the other side. Subtract, and like before you're cross multiplying, y should come below x and 56 should come below 83. So you have x by y is equals to 83 by 56. So we have found a ratio for x is to y. Okay, so what we can say is let the HCF be k. Okay, so then we will know what is the exact value of x. Therefore, what is the value of x? 83k. And what is the value of y? 56k. This is the first part of the question. The second part of the question tells us to prove 3x minus 2y is to 3x plus 4y is equals to 137 is to 473. Remember, the question tells you to show that or to prove. So we need to take the left hand side. So I've written that in the form of a fraction, and remember this, that the value of x is 83k, the value of y is 56k. So we are only replacing these values now here on the left hand side. You'll observe we have only replaced the values. Now you multiply. Okay, now you add and subtract accordingly. So you get 137k by 473k, and you know k and k can get cancelled. So 137 is to 473, which is also our right hand side. So we'll say ultimately, therefore LHS is equals to RHS. We move on to the next question. That's question number 8, number 3. There are also two other questions, that is 1 and 2, where the question tells you what terms would be added or what terms would be subtracted. If the question tells you to add, so we say let the term to be added be x or any term that you like to choose. And if the question tells you to subtract, then you subtract accordingly. After solving this question, you should be able to do number 1 and 2. So here the question says what terms would be added to the antecedent and subtracted from the consequent of the ratio 4 is to 7. So what is the antecedent here? 4. What is the consequent here? 7. So from this term, from this 2 only, we have to add to the antecedent and subtract from the consequent, and see we do not know the term. So we first say let the required term be x, and the question also reads to make a compound ratio of these two terms. Okay, 2 is to 3 and 5 is to 4. So we'll separately find compound ratio. 2 and 4 gets cancelled. 2 ones are 2 and 2 twos are 4. So this is what will remain, 5 by 6. So we know the compound ratio. Okay, now according to the question tells you, again I'm telling you, what is the ratio given to us? 4 is to 7. 4 is the antecedent and 7 is the consequent. The question tells the term has to get added to the antecedent, means it has to added with 4, and it has to get subtracted from the consequent, means it has to get subtracted from 7. So this is what you get, and it has to give you a compound ratio. So that's why we have 4 plus x, that is adding, 7 minus x, that is subtracting. Okay, and it gives us a compound ratio of 2 is to 3 and 5 is to 4, means we have already calculated that. Now you cross multiply, arrange the like terms. So we have x is equals to 11 by 11. So 11 ones are 11 ones, it gets cancelled, and we get the value of x as 1. With this we end the lesson. In case of any doubts or clarification, please get back to me. Here is my contact number.